In the beginning, God created the heavens and the earth. According to the Bible, God created our universe in 6 days. On the 4th day, God created our sun, our moon, and the other planets of our solar system. Then it says, He made the stars also. Is this true history? Is this how our universe came to be? According to secular scientists, the answer is no. Most secular astronomers believe that the heavenly bodies formed by gradual natural processes over billions of years. They say that this idea is scientifically sound, that it's based on solid scientific principles, that it matches all the evidence. But this isn't true. You'll hear me use the word evolution in this video. This might surprise you, because obviously this video is about astronomy, not biology. Well, as you can see by these textbook covers, secular astronomers often apply the word evolution to planets, stars, galaxies, and even the entire universe. In astronomy, the word is commonly used to describe how these objects supposedly formed and changed over time, all by themselves, with no creator being involved. In this video, I'm going to use the word in the same way. If the Big Bang model were true, should we see stars in the sky today? The answer to this will probably surprise you, especially because there are frequent announcements about discoveries of star-forming regions in space, like this nebula. We're told that we see lots of places where stars are forming today. Evolutionists like to point to regions like this as support for their model, but that's a logical fallacy, a red herring. Whether or not stars are forming in the universe today, or whether they could form in the universe today, is not the question. The question is this: if the universe formed itself, as the Big Bang model says, without a creator being involved, would we see stars today? And the answer is no. Here's why. In the Big Bang model, stars are supposed to have formed from clouds of gas, as gravity squeezed the gas together. But there's a problem here. A cloud of gas in space will not collapse into stars on its own. It's true that gravity pulls the gas molecules together, but gravity is a relatively weak force, and it's much weaker than gas pressure, which forces the gas molecules apart. Here's an illustration I like to use. This is a can of compressed air. When I pull the trigger, it opens a passage from outside the can to inside the can. So what happens when the gas can travel freely? It comes out, because gas always disperses from areas of higher pressure into areas of lower pressure. When I give talks about this, I like to ask the audience, how much gas would you need inside the can to create such a strong gravitational force that when I pull the trigger, gas wouldn't come out of the can? Instead, all the air in the room would get sucked into the can, and we would all asphyxiate and die. People laugh because this idea is ridiculous, but that's the kind of concentration of gas you would need to form stars from a gas cloud in space. You can't maintain a cloud of gas at a higher pressure than its surroundings unless you keep it in a container of some kind. This can is a container, so the gas stays inside without dispersing. But there aren't any containers in space, so there's nothing that prevents gas clouds in space from dissipating. Not only that, there are other things that will prevent a gas cloud from collapsing into stars. As one evolutionist wrote, "We know the cloud wants to collapse under its own weight to make one or more stars. But rotation, as well as turbulent motion within the cloud, work against that fate. So too does the ordinary gas pressure you learned about in high school chemistry class. Galactic magnetic fields also fight collapse. They penetrate the cloud and latch onto any free-roaming charged particles contained therein, restricting the ways in which the cloud will respond to its self-gravity." But you might be wondering something by now. If stars are made of gas, and if gas clouds in space will disperse, then how can stars exist? It's because they're much denser and much smaller than the gas clouds we're talking about. Gravity is stronger at higher densities and smaller distances. Therefore, if there's enough gas in a small enough volume, gravity is strong enough to overcome gas pressure. That's why stars are stable, even though they're made of gas. But interstellar gas clouds are too large and too diffuse for gravity to overcome gas pressure. So they won't collapse and form stars. They'll disperse instead. Evolutionists know this is true, but they need to have stars form out of gas clouds in order for their model to work. So how do they explain this? Actually, they have several explanations. First, they suggest that compression can overcome gas pressure and allow stars to form. The compression would come from a supernova. Supernovae are tremendous explosions in space. For a short time, they can produce as much energy as an entire galaxy. They're incredibly violent. For example, the Crab Nebula is the remnant of a supernova that occurred in the year 1054. This supernova was so bright that it was visible during the daytime for more than 3 weeks. Supernovae are thought to trigger star formation when one explodes close to a gas cloud. This creates a shock front, which compresses the cloud, overcoming the gas pressure. Gravity then takes over and compresses the cloud further, and stars begin to form. The second explanation is cooling. When a supernova occurs, it might also inject dust grains and particles into the cloud, or the grains can get there from other ways. The dust cools down the cloud, which reduces gas pressure and again allows stars to form. A third possibility is collisions, where the gas cloud gets compressed when something else collides with it. This can occur when galaxies collide with each other, as you see in this example here. A fourth possible explanation comes from black holes. Some evolutionists suggest that black holes emit jets of high-speed material, which crash into gas clouds and trigger star formation. A final possibility is that radiation from a cluster of newborn stars can trigger star formation within nearby gas clouds. So evolutionists have several explanations for star formation today. But notice something important about these explanations. They all require stars to exist before more stars can be made. Supernovae occur when old stars explode. According to the Big Bang model, interstellar dust grains also come from existing stars. The model can't account for them otherwise. Black holes are thought to form when massive stars run out of fuel or have certain other things happen to them. And before galaxies can collide, they first have to exist, and they're made up of stars too. The same is true for radiation from newborn stars. This is a huge problem for the secular model. The Big Bang can't make any stars until stars already exist. It's like the classic riddle of the chicken and the egg. You need chickens to make eggs, and you need eggs to make chickens. The Big Bang model has this problem on a much larger scale, a universal scale. It can't make stars until stars were already made. Add up all these problems, and you see why evolutionists say things like this. The origin of stars represents one of the most fundamental unsolved problems of contemporary astrophysics. There are so many uncertainties in this picture that at present we do not really have a theory of star formation. If stars did not exist, it would be easy to prove that this is what we expect. Most of us are persuaded that stars form out of more diffuse material, which must, therefore, condense, contract, accrete, etc. Nevertheless, nearly all observations of pre-main sequence and protostars are dominated by outflowing stuff. Literally hundreds of ideas on how stars were formed have been advanced in past decades. However, we are still far from any real solution. We're starting from a shaky foundation. We don't understand how a single star forms, yet we want to understand how 10 billion stars form. If none of us knew in advance that stars exist, frontline research would offer plenty of convincing reasons for why stars could never form. Remember this the next time you admire the night sky. All the stars you see, and billions more that you don't see, all defy the evolutionary model just by existing. Now some people will claim that what I just said isn't true. They'll say this problem has been solved because there were some announcements recently that claimed that it was. For example, here's a report about a computer simulation that supposedly showed how the very first star could form. And here's another. But here's what they aren't telling you. These simulations all require something called dark matter. And if you ask an evolutionist what dark matter is, they'll tell you they don't know. Many astronomers believe that there's a lot of stuff in the universe that we can't see. There's supposed to be a huge amount of it, 5 times as much as all the stars and galaxies and everything else that we do see in space. But if you ask where all this matter is, they'll tell you it's invisible. It emits no light. It emits no radio waves. It emits no X-rays or infrared radiation. It's unlike everything else we know, but it must exist, or else their models don't work. We'll talk more about dark matter in the next video in this series. For now, I just want to point out that in order to explain where the first stars came from, evolutionists have to invoke things that nobody has ever seen and that nobody has any idea what it is or how it works. As a cosmologist recently told the BBC, "We don't know what the dark matter is. We don't know what the first stars are. If we bring these two problems together, when we know more about one, then we can say something about the other." Well, that doesn't work. Being ignorant about two things at the same time doesn't teach you anything about either one. If we don't know what dark matter is, how it works, where it came from, whether or not it could even have been formed by the alleged Big Bang, how it behaves, whether or not it interacts with ordinary matter outside of gravity, or anything else, then how can we make it part of a scientific model? The only reason dark matter can supposedly rescue star formation for the evolutionists is because nobody knows what it is, or has any definitive evidence for how it might work. So evolutionists are putting it in their models and claiming it can do all sorts of wonderful things because nobody can prove that it can't do all these wonderful things. But that's not how science is supposed to work. And even then, scientists have realized that not even dark matter can rescue the Big Bang from all its problems. So evolutionists also believe in something called dark energy. Together, dark matter and dark energy must be about 96% of the universe, or the Big Bang model can't work. But neither dark matter nor dark energy has a solid basis in physics. As the director of the Canadian Institute for Theoretical Astrophysics said, "We know the total matter content of the universe. It's 4%. That's the stuff we recognize as matter. The rest is something we don't understand." There was an article in the New York Times that talked about this. It talked about how the Big Bang cosmology depends on dark matter and dark energy. The article asked, "What is dark energy anyway?" And then it said, "The difficulty in answering that question has led some cosmologists to ask an even deeper question. Does dark energy even exist? Or is it perhaps an inference too far?" Cosmologists have another saying they like to cite. "You get to invoke the tooth fairy only once," meaning dark matter. "But now we have to invoke the tooth fairy twice," meaning dark energy. So evolutionists make jokes about how their model doesn't work unless you invoke the tooth fairy. Meanwhile, the public schools are teaching our children that the Big Bang model is true. There's a serious problem here.